the homebrew key made from Bunnings bits. Well, hi folks, welcome to another episode of The Art of Engineering, and today's episode will be Battle of the Birds. And this, folks, is my old school Renaissance rig. It's a single tube rig, and I actually hand ground some crystals, the old school crystals, to get them up to the correct frequency. So we're going to test to see how many watts we get out with the 6V6, and then we're going to swap in the 6L6 and just see whether that makes any difference. And then, of course, we're going to reinstate the voltage doubler that was in here, which made the voltage too high for the 6V6, but it'll be okay for the 6L6. So we may even try it on a higher plate voltage if we're getting a little bit more watts out. It should be a lot of fun to play around with. Now, 2.5 millihenry chokes are quite hard to come by for these rigs. So I've hand wound one of these chokes, and that's also a video below. And like I said at the beginning here, I think I said at the beginning, this is an Amico clone, but it runs on 12 volts DC because I've put an inverter in this rig. So lots of fun stuff happened with this rig, and I haven't stopped playing with it, and I've always thought it'd be nice to get a little bit more power out of it. So let's see if that's a possibility. I don't know, over here we have the QRP playground, and you know, I will still use this rig at QRP a lot of the time, but every now and then we like to bust out, don't we? Hello fellow hams, I'm going to ask you a small favour. If you like watching these videos and you haven't already subscribed, reach down and smash that subscribe button just like it's a Morse key. And if you like the video, maybe hit the like button too. Anyway, back to the video. So ladies and gentlemen, as you can see, I've actually got 3 of these wonderful tubes that Chris provided. And he's also provided, as it turns out, I bought that dummy load, this old school dummy load that's in the background here. It is a thing of beauty. I might show it off later. But first cab off the rank is going to be our 6V6 original tube. And I think from memory, stop kicking the tripod. And I think from memory, it's going to give me about 5 watts with this older school crystal that I did a video on hand grinding it. It was originally in the 6 megahertz band, 6940, and I managed to get it up to, I think, at 7214 is where I stopped, but I probably could have gone a bit further. But I'll stop while I'm ahead because I have another one that I can grind a little bit more viciously and see if we can get any higher up the band. Anyways, I'm going to plug this tube in, and we are going to see what happens. Now, this tube, I did have a little bit of a near miss with it on one occasion, but I don't think it's affected the output. So let's go turbines to speed. Hopefully, no smoke comes out. I've been playing around with this for a while, so thus far, it's looking pretty good. Are the filaments coming on? Yes, the filament has come on. That's also a good start. Now, I need a key in this, don't I? Let's get a key. The homebrew key made from Bunnings bits. I love this key. Okay. So hit transmit. Well, folks, after a monumental amount of time friggling and gajiggling with this transmitter, we're getting about 4.5 watts. That's the 5 watt scale. So 4.5 watts is maximum output on my 6V6. Let's chuck in the 6L6 and see if we get more power. Yes, it was a little bit warm. I probably should have waited. Ouch. Okay, let's plug in this much larger tube. I probably should check to see if the pinout's the same. I guess I'm going to find out. Maybe the hard way. Fingers crossed. Turbines to speed. Is the cathode coming on? I think it might be coming on. Yes, it is. Is it the same tune point? Who knows? Oi, okay. Let's take it to the 20 watt scale in case. And it's giving me about 6 or 7 watts. Yes, so only a couple of watts extra. But that is with the current plate voltage, which is, I think it's below 300 volts. And I think I can get up to over 400 volts if I reenact the voltage doubler in this transmitter. So the score thus far, 6V6, 4.5 watts, and 6L6, probably 5.5 watts. So it's only a watt and a half difference thus far. But let's play with that plate voltage and see if we can get it even higher. That's the project for this video. Well, it's a rainy Saturday night. I'm hoping that the rain noise on this metal roof isn't too distracting. And so far, in the battle of the bulb, the 6L6, the big brother of the 6V6, a watt and a half difference. But wait, presently I have the plate voltage set to about, I think it's, hold on, I've written it down. The 6V6 is on 252 volts presently. So that means that 252 is being presented to the 6L6. Now the 6L6 will take a maximum of about 500 volts, if my calculations are correct. Comment below if you think I'm going to make smoke soon. And if I use the voltage doubler in the circuit, which I experimented with earlier in the construction of my AOE One Tuber Renaissance rig, I end up with 498 volts. So I'm going to reinstate the voltage doubler and just see how much raw grunting power I can get out of the 6L6. Now, as I always state in these videos, this is not a how-to video. There is dangerous voltages associated with tube equipment, so make sure you know what you're doing before you proceed. You proceed with due diligence and a huge amount of care. This is the filter board and the bridge rectifier that comes out of this little inverter here. So basically what happens is this, I bought this inverter off AliExpress. This is an idea I got off Microwave Mike. This is not my own idea. So I'll put a link to Microwave Mike's channel below, and also links to all the videos that are pertaining to the building and the play with this fantastic one tube rig. It's just a blast from the past, the sort of thing that a novice would have built in the 1950s and 60s, except that of course they would have built a power supply to power it. Instead, I've got an AliExpress car inverter. So if you've got 240 volt equipment you want to operate from your car, you use one of these. So what I'm doing is I'm putting 12 volts into that and getting my 250 volts AC out. And for this 6V6 tube, I was just rectifying that and filtering it with these capacitors, which I got. They're high voltage capacitors that I got out of old switch mode power supplies that I had in the junk pile. But what I'm going to do is, I had this originally set up as a voltage doubler, but the voltage was too high for my 6V6, and I didn't want to blow up the one tube that I did have. I've now got more than one tube, so I can afford to play, and I'm pretty sure 498 will not be a problem for the 6L6, and we may or may not get more power out of it. So I'll reinstate. It's only one wire that needs to be relinked back in here, and get that all going back inside the transmitter, put the bird's nest back together again, and we shall power up and see once and for all how much power I can get out of this 6L6. Let's go. Okay, we are back in the QRP playground, hoping that this doesn't explode in my face. Can I have a clear prop? Oh, it's saying 19 amps. That is not good. Something not right. Uh-oh, we have decided, hey, we have the technology, desoldering equipment, you know, all the gear, no idea. Like I said, you proceed at your own risk. This is a device that has high voltages in it that can cause you serious injury if you do not know what you are doing. What I've done is, this is called the H bridge. When I pulled out these FETs from the H bridge, these are indicating either diodes or sometimes resistors. But this one here that I pulled out and stuck in the component tester is telling me that it's an NMOS, and the other one is telling me that too, and they're all the same type of FET. So two of these FETs are dead and need to be replaced. I will try and find something I can pop in there and get this circuit going again. You may very well wonder why I'm wearing safety glasses. I'm about to test the repair that I've done to my inverter, and having been at the receiving end of exploding FETs in the past, I would like to exercise, if not caution in my replacement components, at least in what happens after I switch it on. Let's see what happens. Okay, a voltmeter is set up, and we've replaced 4 FETs. Now the 4 FETs that we've replaced are these ones just over here. And have I gone to an equivalent component? No, I've just gone with what I've got. I think ratings wise it's okay, but you know, gate capacitance, all that stuff, completely different. So this circuit very well may not work at all. Nothing ventured, nothing gained. Fingers crossed. Let's have a look. We've made some more smoke. We hit the switch on the power supply. Could smell that horrible smell. Heard a fuse go pop, and what I did was really dumb. I've changed, you know, once again, just going, oh, well, let's do a random change of some active components and see if we can get it to work. Get lucky sometimes. Quite often you create more problems than you solve. So what's happened is, I should have checked on the input side. There was 2 FETs on the input side, and I think one of them was short circuit. Now, should I take out all the other transistors before I test it again? Probably I should, but once again, I'm going to go dumb, take chances, see what happens. Also, my component tester is playing up at the moment as well. It was working and then it stopped working, so I'm going old school on checking the FETs, and I'll show you what I'm doing there to ascertain whether they're dead or not. Let's put the camera up high so we can have a look down. So we've got gate, drain, source, an N-channel FET. We're on diode test here. Black to the center lead. We can short out those 2 pins with our fingers, the gate and the drain. Get them shorted out. And then if we put our black in the middle on the drain and our red on the source, we should get a reading. And then if we reverse that situation, we should get open circuit, which we have. And if I leave my black on the source and I tap the gate with the positive lead, this suddenly becomes open circuit sometimes. There you go. So that is indicating that that FET is working. Now, the one that I took out that I think is a dud, if we go black to center, we'll short the 2 pins out, gate to drain. In fact, I'll put the lead right across them to make sure. Okay, so now if we go black to center and the source, we've got open, so it's working. We've got a reading, which we expect. But then if we go reverse of that, we should have an open circuit situation, and we don't have an open circuit situation. So this FET is dead. Okay, a voltmeter is set up, and we've replaced 4 FETs. Now the 4 FETs that we've replaced are these ones just over here. And have I gone to an equivalent component? No, I've just gone with what I've got. I think ratings wise it's okay, but you know, gate capacitance, all that stuff, completely different. So this circuit very well may not work at all. Nothing ventured, nothing gained. Fingers crossed. Let's have a look. Okay, folks, this is the absolute final attempt. I've rated bets that I don't know what make they are, what ratings they are. I've just ripped them out of switch mode supplies randomly, and we are going to hit start on this power supply, and I've got the safety glasses on. Let's see what happens. Can I have a clear prop? I'd say we're not going to be repairing this anymore. So I guess the suspense is killing you. I won't keep you waiting. The inverter transmitter has cooked itself. So I had a DC to AC inverter that's used in cars from AliExpress. So I put 12 volts in and I get 240 AC out, which I was then putting through a full wave bridge rectifier to produce the plate voltage. That has cooked itself. Even when I isolate it, it is dead. So the plan, you know, disasters like this are great. I've ordered on JCar, not the cheapest way of doing it. I've probably gone on AliExpress and waited for them to arrive, but because they're going to be heavy, they're going to take a long time to arrive. So what I've done is I've ordered two 6 amp 12 to 30 volt transformers from JCar, and those two cost me $72. So it's not the cheapest way of doing things. They'll go back to back. So I'll go 240 and then I'll go 30 to 30 and then come out 240 at the other end. Now in the middle there, where you've got your either 12 volts or 30 volts, I'll probably go 12 to 12. I can then take that 12 volts and I can do stuff with it to produce the various filament voltages that I might want to use. And then on the output, I'll probably take the power supply board that I've got in the AOE one, and I will use that and the voltage doubler on that circuit and the switch maybe, so I can switch between a very high or slightly lower plate voltage. So that's all coming up in future episodes. So stick around for future episodes, and if you haven't hit subscribe, because down the track we will get the one tuber going again with the 6L6 tube in it, and we'll just see how much power we can get out of it. Thank you for sticking around right to the end of the video, 7-3, and I shall see you in the next episode of The Art of Making Smoke and Disaster, aka The Art of Engineering.